because we do, like I said, have a lot to get over, because I did kind of do overkill with this, but okay. So number 1 and number 2, even though they have different directions, basically it's asking you the same thing, which is it a function? So for both cases, both situations, you're going to use the vertical line test, okay, for both of these, right? With your little pencil or your finger, and you're going to move across there, and all you're trying to find out is, do you ever touch the graph in 2 or more places at the same time, okay? So as I move across this little dude here, what do we think? Yeah, he's a function. Yes, he's a function. Okay, we used vertical line test. We only touched it in one place at a time. Okay, what about this little absolute value guy? Yeah, look at him. Yay. Okay, he's a function. All right, what about this weird dude down here? He's a piecewise. That's okay, it doesn't matter. But does he pass the vertical line test? Yeah. Okay, and what about the last one over here? Yep. Okay, so as you can see, Ms. Holcomb made 4 horrible examples because she never gave you a no. So let's talk about what would be a no, okay? Because all these are yes. All right, so what would be a no? Okay, you only have 2 situations where you're going to have a no. One of them would be a circle, hint, 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 okay? Why would this be a no? Because you're touching it in 2 places at one time, right? Every single, I mean, look at the y-axis, for crying out loud. That shows you that a vertical line is touching it in 2 places. So circles are not a function, okay? Then the only other situation you might encounter, okay, would be some type of situation like this, or a piece of a circle, like a parabola that fell down, or like an arc of a circle. Sorry, Joy. Okay, that, then obviously that way you would also be a no. Okay, so we're talking about a circle or an oval or a part of one of those. Those would be your no's. Everybody else is yes. I did, thank you, dear. Yeah, let me make sure, but yeah, I did. Okay. Okay, all right, moving right along here. Making sure it shows up on both screens. Okay, so number 3. Number 3 wants the domain and the range. That's all you have to tell is domain and range. And it wants interval notation. Okay, so we're going to, and then 4 is going to be the same thing. So we're going to kind of move a little bit fast here because I want to get to the stuff in the back that's a little harder. But let's look at his domain and range first. Okay, so for the test and for this study guide, any number you come up with is going to be a hard bracket, right? All the infinities are going to be parentheses. Now, there's also another parenthesis situation that would eventually occur, and that would be with an open circle, but you're not going to have that, okay? So all your infinities are parentheses, all your numbers are hard brackets. So a domain, to find it, you're moving left to right. That's how you find domain. So we're over here on the left, and I really don't encounter my graph until right here. But remember, a domain is an X value. So I'm not looking for 1, that's a Y value. What's the X value right here? 0. Okay, that's a number, so hard bracket. And then it goes all the way to what on the right? And that gets a parenthesis. There's your domain, okay? All right, let's look at range. Range moves from bottom to top, okay? So we're down at the bottom. I don't encounter the graph until I get here, right? Which is a 1. And then even though it looks like it's kind of flattening out, it's not. It's getting higher and higher and higher and higher. So where is it going to end? Infinity. Yes. So range is Y values, domain is X values. Yep, yep. Okay, let's try it again. Okay. Now we have this guy. We have a parabola turned upside down. Okay, so domain is going to be left to right. Okay, be thinking about this. Where is this going to end up, or where's he coming from? Negative infinity. And where does he end up? Positive infinity. Because remember, it's a bowl that's getting bigger and bigger and wider and wider. Okay, now let's try range. All right. So we're starting at the bottom, which would be negative infinity, and we're going all the way up to where? 4. Be careful here. I get a lot of students that want to say 3 because they see a 3 on the y-axis. Well, that's the y-intercept, but you got to go all the way to the tippy top, right? And the tippy top says 4 with a hard bracket. Okay, so domain and range. Is that good? Okay. All right. Then we want you to do a domain and range with a little mapping problem. Now, this one has different enclosures. Okay. This one, these are points that are on a graph. So we don't want to use a hard bracket and we don't want to use parentheses. These are going to be curly brackets. Okay. So my domain and my range for the mapping are going to be curly brackets. All right, first question wants to know, is it a function? All right, remember to tell if it's a function, and it is a function, good. You cover up the y's, you cover up this side, and does every single x have one line coming out of it? Yeah, so he is definitely a function. Because remember, these are your x's, these are your y's, right? So these are your, this is your domain, this is your range. So my domain, I'm just going to list these. In my range, I'm going to list those. Okay. Do not put 1-3 because that's not true. It's not everything from 1 to 3. It's not 1.1. It's not 2.5. It's 1, 2, and 3. So you put them in curly brackets with parentheses. With commas. Okay. So that one's a little strange, but that's what it is. Is that okay with everybody? Curly brackets, commas. Okay. All right. Awesome. Okay. Let's move on to 6. All right. We want to know yes or no. Again, that's all you have to write. You don't have to tell me why, but we are going to talk about why. So is it a function? Now, one thing you could do is you could create those mapping diagrams. You could draw the ovals and put all the x's in one and all the y's in the other. And you can draw your lines and you can look at it. But basically, it is a function if your x values do not repeat. That's the key. Okay? So we're not worried about y. We're just worried about x. Okay? So as you're looking through here, let's talk about a first. Is a function? Nope. Why isn't he a function? Yeah, -3 is repeating. So again, you don't have to tell me that. You just have to write yes or no, but that's why. Okay, what about B? Yeah. Now, does it matter that the 3 in the y position is repeating or the 0 in the y position? No, because we don't care about the y's. Good. Perfect. All right. Next one, 7. Okay, I know there's a lot of rules for this test. This test is rule heavy. I'm sorry, but this one wants to know, is this a function for each one? Now look at the way that it says it. A lot of students don't like the wording, so I just tried to put this is exactly the same wording as the test, okay? So what this means is this a function? Now, if you have an equation, your rule is y cannot have an even exponent, okay? That's the rule if you have an equation. Again, I'm sorry about all the rules, but there you go. Okey-doke. All right, so is a function? Yeah, he's a function. Let's talk about it. X has an even exponent. That's okay. Y has an odd exponent. All right, we're good to go. Is B a function? No, because Y has a 2 on it. Okay, so on one hand, these are super easy problems because it's just yes or no. On the other hand, you got a 50-50 chance. And if you put the wrong answer, there's no partial credit, right? You like miss the whole thing. So that kind of stinks. All right, here we go. Now we're going to do intercepts. All we want are the intercepts. So let's see. Let's find x-intercepts and let's find y-intercepts. And then I'm going to have you do one other thing, and then we're going to put an extra little problem down here. So don't turn the page too fast for my fast movers. Okay. First of all, x-intercept. How do we find those? Yeah, it's wherever it touches the x-axis. So you can write 2, or if you want to be really precise, you can write 2, 0. I'll take either one. Okay. What about my y-intercepts? There's just one. It's right here. It's -1, or you can write 0, -1. Okay. What if you, hint, hint, okay. What if you have like a circle or an oval or whatever shape that is Ms. Holcomb just drew? Okay. So in that case, how many x-intercepts do I have here? I have 2 of them, right? Let's pretend this is -3. Let's pretend that's +3. Okay, so you have 2, you have to write. You can write -3 and 3. You can write -3, 0 and 3, 0. You know what you can't write? This. Is this an intercept? No, it doesn't even have 0 in the y place. Don't do that, okay? So you can just tell me them separately. You can write them as points, whatever you want to do. And then if this were, I'm all out of creative ideas. Let's make that a 3 and -3 too. Okay, so my y-intercept, again, you could do -3 and 3, or you can do 0, -3, 0, 3. Just don't write them together with a comma, okay? Everybody all right on that? Okay, let me do one more while we're on here real quick. I know, it's just crazy. Okay, what if I also, I'm trying to figure out, why did I choose to do that here and not over here? Never mind, that's all I'm going to do here. We'll do it on the other side, on the other page. Okay, everybody okay on that? So you may have more than one intercept, and if you do, you just write them both. Okay, all right, here we go. You have 2 graphs. Okay, we want you to identify the intervals where they're increasing, constant, and decreasing. This means x values only, and you're going to use all parentheses. Okay, oh, guess that would help. Okay, x values only, all parentheses, because remember, these are the intervals where it's increasing, decreasing, constant. We can't use hard bracket because then you can't claim the transition points. You can't tell where you're transitioning there, okay? All right, so let's do both of these just to make sure that we're comfortable with it. This is a really bad example, but you know, I didn't want to draw it for you, so I cut and pasted it out of the book. Just pretend this is all one increasing situation. You don't have anything weird like that on the test. Okay, just pretend that's a straight line right to there. Okay, so let's do this guy first. All right, so on the graph, where is he increasing? I'm flat, I go up, and then I'm flat. So he's increasing here, right? Okay, we're going to use parentheses, and we're going to use x values only. So he starts increasing at -2, and he stops increasing at 4. Everybody agree with that? Sound good? Okay. All right, constant. Those are your flat areas. I see 2. I see this one, and I see this one. Okay, so we're going to have 2. So our constant's going to be, where does he start over here? Good, -infinity, and he's going to go to 2. All right, then he starts being constant again from 4 to infinity. And there we go. You can put a little comma between them. You could leave it blank, whatever you want to do. Okay, perfect. Now, is he decreasing at all on this graph? No, so just none. Okay, awesome. Everybody okay with that one? All right, let's try his little friend. Okay, so here, A, B, C. Okay, I'll just do it over there. All right, so remember, you can't look at the arrows, okay? You can't look at the arrows to decide the motion. You have to trace it with your pencil. So this little piece right here is not a decreasing. Trace it with your pencil like you're drawing the graph. This is going to be increasing, then decreasing, then increasing, then decreasing. So for A, for increasing, I start increasing here. Now I know it looks like it's going straight down, but you guys have been in math long enough to know, where's it actually going? Yeah, it'll get there eventually. And then it's going to go all the way to 0. Okay. Then where does it increase again? Now this one's a stinky problem because it's like a decimal. Yours will be a nice clear situation, but what's the X value for where it starts increasing? Yeah, like 1.5. And it's going to increase to 3. Does that look good? Okay, let's talk about, let's see, B is constant. Are there any constants for this guy? Any flats? No, none. Okay. All right, where are we decreasing? Well, again, if you draw it with your pencil, you're decreasing from 0 to 1.5. And then you're going to decrease again from 3 to where? Oh, be careful. 3 to where? Infinity. I was waiting to see if anyone yelled out negative infinity. Be super careful there. I know he's going to negative infinity for the Y values, but be careful. Where is that one actually headed for the X values? Positive infinity. Does that make sense? Be careful on that. All right. That's a common error for this test. Okay. Now we're going to look at some graphing. You okay? I know we're going fast, but I just want to get to the end. Good. Okay. All right. So it gives you some crazy graph and they give you grids so we don't have to worry about our ladies cocking our paper the sideways, you know, like we talked about. Okay. So find f of -2. What is it saying? What is -2? X. This is saying X is -2. It wants you to find Y. That's what it's telling you. Okay, so let's see. -2 is right here for X. And if I find the graph, it's way down here at the bottom, this little dip. So what's my Y value there? -4. That's your answer. Perfect. Okay. What about f of 3? What's it telling you? What's 3? X is 3. So that would be, oh, right there. What's my Y there? 0. Okay, I'm going to add one in for you. Okay. What if it tells you oh, never mind. It doesn't tell you that. That's all you got. Awesome. Check off. Okay. Okay. I thought maybe we had one that went the other way, but we don't. Okay, good deal. All right, number 11. Okay. You've given the graph below, find the relative minima and the relative maxima. Give points. Remember, all that means is this means the bottom points where they change transition, the dips, right? And they say relative because that means you clearly see it start to come back up. They use minima in case there's more than one. And in this case, there is, right? There's more than one. So it just means the minimum points. Okay, then the relative maxima. Be careful. It's not these guys on the end. Those are the absolute maximums. They're going to go on to infinity. But the relative one means where you see it change direction and form like a little peak. So it would be right there. Does that make sense? Okay, so let's see. Let's find our minimums first. Okay, so I see 2 little points down here. That would be minimum points, and it wants the points. So this would be -3, 0, and this would be 3, 0. Okay, what would be our maximum? Perfect, 0, 4. Good. Now be careful. This problem on the test is tricky because it's multiple choice. And I know you're thinking, how can that be tricky? Because here's what they do. They'll say, give the relative minimum and relative maximum. So this is how you think your answer would appear. But guess how it appears in the multiple choice? They're going to switch it and give the maximum first and the minimum second. And so one of your choices will be this, which would be great, right? This is the choice you want. But they're also going to have this with these switched, where this says this is the max and this is the min. See what I'm saying? They're going to switch these words on you. And if you're not paying attention, you're going to see the points and go, oh, that's the one, and you'll mark it correct. And it's not right. And because it's multiple choice, I can't give you any points. Okay. So make sure that you not only find the points, that you're really clear about which ones are the maximum and which ones are the minimums. I hate that question, but I can't take it all. So, okay, just pay really close attention. All right, well, we don't have to worry about number 12. That's not going to be on there. So you can go on right through that one. Okay. They are going to want you to find the slope of a line that goes through given points. Now, we don't have to go through all these. You're going to worry about A and C only. Okay, that's all you're going to have to deal with. All right, well, we're going to need a formula. So what's the formula we need to find a slope with 2 points? Okay, I think I hear mumbling through masks. Okay, so y2 minus y1 over x2 minus x1. Okay, make sure you've got that somewhere in your little brain. All right, so let's try A. So again, there is no shame in writing down x1, y1, x2, y2. Do it. Give your brain a break. Okay, then all you're going to do is plug and chug, right? You're just going to put those right in there. So y2 is -4 minus y1 is 3. x2 is -2 minus x1. Here's where the mistake happens. So be careful. Put that negative guy in parentheses so you don't lose his sign. All right, my numerator is -7. What's my denominator? 0. Okay, undefined. Now, if you're not sure if it's undefined or if it's 0, how are you going to check and see? Put it in your calculator. If you put -7 divided by 0 in your calculator is going to go, error. That's your calculator's way of saying undefined. Check yourself. You don't have to guess. You don't, and don't leave it -7 over 0, please. Okay. Is that one all right with everybody? Yes. Okay. All right, let's try this guy. Again, let's label. Okay. All right, we're going to plug in. We've got 8 minus 7 in the top. Oh, I'm on the wrong one. Never mind. Sorry, guys. Try that again. I have 3 minus -4. Okay, again, there's your mistake. So you want to put it in parentheses. You don't lose your negative. 2 minus -1. Okay, what's the top going to be? Nice 7, the bottom. 3, can I reduce that? There you go. Okay, awesome. Okay. Number 14. Okay, we're going to do A and B for 14 because we want to practice. Okay, so this says use the given conditions. We have a slope, we have a point. To write the equations for the lines in point slope form and slope intercept form. All right, let's see if we remember the forms. So this we're going to have to remember, this little slope equation, right? Remember him. Okay. Now point slope form we're going to have to remember. Okay. So remember he's y minus y1 equals m times x minus x1. That's point slope form. You guys are pretty good at knowing slope intercept, but it's y equals mx plus b. Okay. Now here's the deal. You can't get to mx plus b form unless you have a y-intercept. You are never going to be given a y-intercept. So even if it only asks for this, hint, hint, even if it never mentions point slope and all it says is, give me slope intercept form, and this is what it gives you, You have to remember, be smart enough to remember, you don't have the right information. You are going to have to go through point slope form. You're going to have to, even if it doesn't tell you you need it. Okay. All right. So here's my M and here's my X1, Y1. Okey-doke. So for point slope, all I'm going to do is plug it in. Y minus Y1 equals, there's my M. X, now what's minus -6? +6. There's point slope. You did it. You don't want to distribute. You don't want to change it. You're good to go. Okay. All right. Now for slope intercept, I do have to rearrange. You're trying to get Y by itself on the left. So first thing I'm going to do is distribute the -3 through there. Okay. And then I'm going to add 3. So I get Y equals -3x minus 15. And there we go. Okay. I think for the sake of time, I'm going to let you practice B on your own. The answers are in the back. Oh, Samia. You good? Okay. All right. Is that okay if I let you do B on your own? The answers are in the back. All you got to do is plug them in, distribute, solve for Y. Everybody okay on that one? Okay. All right. Let's look at 15, but we're only doing 15A. So you'll cross through B. I don't even want you to put it in your little brain. Okay. Are you good, Maria? You sure? Can I change it? All right. Okay. Okay, so we don't have to worry about him. Why are we not worrying about him? Because you're not worried about parallel. You want the one that says perpendicular. That's what you want to practice. So let's talk about this. It says use the given conditions to write the equation for the line in the indicated form. Okay, what form do they want? We'll skip to the good stuff. Point slope form. Okay, so we already know that we want to end up in point slope form. That's where we're headed. And then we can stop when we get there. Okay, so we want to pass through this point. Fantastic. We have X1, Y1. And we want to be perpendicular to this line. Ooh, okay, hold on. We don't have a slope, but this one gives us one. Oh, okay. So what's the slope of this line? 1/3. Everybody agree with that? That's the slope of that line. It's just what it's X. Okay, if I want to be perpendicular to him, I'm going to use this slope, but I'm going to do 2 things to it. Opposite or negative reciprocal. So first I'm going to change his sign. He's a positive 1/3. I'm going to make him negative. Second thing I'm going to do, flip him. So if he's 1/3, I'm going to get 3/1, but I only need 3. Okay, so for perpendicular, you want opposite sign and flip. That's what you want. Do both. Okay, some students, you just don't want to commit. You'll do one, but you won't do the other. I don't know why that is. Okay, all right, now we're ready. We're just going to plug it in. So Y minus Y1 is a Y plus 3. Remember our point up here? Equals -3. There's your slope. X minus X1 is a positive 2. And you're done. For some reason on this problem, about half the students will stop there like they're supposed to, and the other half will keep on going and give me slope intercept form. Don't keep on going because that's not the form I want. This is what I want. Okay, so pay attention to the form. You're done. Okay, is that all right with everybody? Good. Okay. All right, let's look at 16. 16 is meant to speed it along. It's one of those gimme easy questions, but students get stuck in it. Okay, so all I want is the slope. Okay, they're giving you too much information. They're giving you way too much. I don't care where the line's going through. They're trying to trick you. Let's think about this. what is the slope of every vertical line in America? Yeah, remember I'm skiing and I fall off that. Okay. All right. What is the slope of every horizontal line? There we go. Remember, that's the one if I'm skiing, it's like 0 fun, right? I'm just walking in funny shoes. Okay, so 0. So don't get bogged down with that. I get students that will cover their paper in formulas and different, they're just all over the place. And I'm like, come on, you know? So it's either undefined for vertical or it's 0 for horizontal, okay? So don't let them trick you with the extra point, okay? I know, right? Okay, here we go. All right, find the function f at the indicated values. All right, we got a piecewise here. So this says f of x equals negative 3x if your x is less than 2. F of x equals x plus 4 if your x is greater than or equal to negative 2. So I get some students that they'll take their little value because what does this negative 5 mean? What's negative 5? Okay. They'll plug it into both and they'll give me 2 answers just in case. Don't do that. That's cheating. Okay. So you only are putting it in one. You figure out which one. For each thing, you have to choose one only. Okay. So if x is negative 5, am I going to use the top one or the bottom one? The top one. How do you know to use the top one? Yeah, because the top one says x is less than negative 2 and my x is negative 5. So that's the one I'm going to use. So what is f of negative 5? It is negative 3 and I put in negative 5 for x. My answer is 15. That's it. Okay, I think you were traumatized at some point in your life by piecewise functions. Okay, let's try this one. This tells me x is negative 2. You can only pick one. So is negative 2 going to go into the top or is it going to go into the bottom? Okay, and we know that because we look at the little condition. It says the bottom one is good if x is greater than or equal to negative 2. That's a tricky one, equal. So we know that's that one. So f of negative 2 is going to be x plus 4, but we're going to put in negative 2 for x. And our answer is 2. It's that simple. That's it. Okay, is everybody all right with that? Okay. It's not gross. Okay, 18 is not gross. Okay, here we go. All right, so this gives you an F, right? This gives you a G, and then we have these crazy directions here, and you should see the things students do. It's like ridiculous. Okay, we're gonna work from right to left. That's what we do anytime we see this little open dot, okay? Because this means we have a composition. So here's what we're gonna do. First step, we're gonna put negative 2 into F. That's what we're doing. That's our first step. We're gonna put negative 2 into F. That's what that means because we're reading it right to left. Okay, so I'm gonna come over here and I'm gonna put a negative 2 into F. Everybody agree with that? This is my first step. Okay. This gives me negative 4 plus 3 over 5. Okay. This is going to be negative 1 over 5. Now I know that is a gross answer, so okay, it's kind of gross-ish. But yours is going to be a nice little whole number on the test. You won't have a fraction. Yours will be a nice little like 2 or something. Okay. All right, that was my first step. Okay, my second step is to put that answer into where? G. Now we're going to put that answer into G. Okay, and then you're done. So unfortunately, yes, I have to put negative 1/5 into G. Yours won't, you won't have to do that. It's going to be a nice little whole number. But let's work through it. So we get negative 3/5 minus 1. If you have the big calculator, you can do that easily. Otherwise, I need to change 1 into 5 over 5. anything with a denominator of 5. So 5 over 5. And I get -8/5 as my final answer. But you're going to have a nice little whole number. You do not have fractions. Okay, just remember, right to left. So we put -2 into F. We did stuff. We got an answer. Then we took that answer and put it into G. That's all you got to do. Sound good? You can do that, especially if it's a nice little answer. Okay. All right. Can I switch? Good. Okay. All right, let's look at 19. Now we're not going to do all 3 of these. We're going to do A and C only. Okay. And we're not going to freak out and continue on till the end of time. We're just going to do what we got to do and be done. Okay. So we want to find F plus G. Well, here's F, here's G. Let's plus them, okay? Let's plus them. There's F. Well, let's add it to G. Okay, now we got to clean it up. All right, we'll put x squared in the front. We have 2x plus 1x, that's 3x. -1, -2. There's your answer. Sound good? Okay, C wants you to divide them. You don't actually have to do any algebra here. Just put the correct one on the top and the other one on the bottom and be done with it. So here it said to put F on top and put G in the bottom. You're done. I get students that are factoring, they're canceling, they're doing, you know, just stick it on one on the top, one on the bottom, you're done. That's it. Nope, nothing else. You're done. That's all they want. You can factor him if you want. Well, no, I don't even think he factors, but he's not going to cross out. So you're good. Right. And you don't need a domain, so you're good. Everybody okay there? All right, speaking of domains. All right, so we want A, C, D. This is probably the most missed problem on the test, and I don't know why. These different ones, they shouldn't be, but okay. So remember, your domain is all real numbers unless you have a denominator or a radical. So do I have a denominator or a radical? No. So I need to put it in interval notation. So how do I write that for my domain? There's my domain. Okay, that's it. All right, so I don't have to worry about him. Okay, now C, I have a radical. Okay, does anybody remember the rule for a radical for his domain? I'm going to set him greater than or equal to 0. That's the rule. So notice this for a radical. Okay, whatever's inside is greater than or equal to 0. Now I just have to solve. So I'm going to subtract 19. All right, unfortunately, can I leave it like this? Okay, I got to divide by a -1, and then what does that do to my sign? He flips, right? Okay, if you want to graph him on the number line, you certainly can if that helps you. This is going to be a hard bracket, and he's going to face the door or the window? The door. Well, my door, right? Is it still your door? No. He's going that way. Okay, so that's going to be -∞ to 19. This is your answer. No, it's facing your window. Sorry, I shouldn't ask that. Confuses everybody. Never mind. All right, is everyone okay on that? Okay, here's the toughie then, down here. Well, not tough, he's just weird. Okay, so I have a denominator. And if you have a denominator, you're going to have to factor, set your factors equal to 0. So factor, solve for x with our denominator. Okay, so he's a nice little monic. You're going to throw your x's in. You want factors of -32. So somebody's positive, somebody's negative. Good. And they want to add together to give you +4. So 4 and 8, And Samia said, put the 8 positive because we want a positive 4 in the middle. Okay, is everybody all right with those? Okay, now we're going to solve. So this one's going to become -8. This one's going to become +4. Now remember, we don't want those to equal that. So to put this into interval notation, I'm running out of room. Okay, let me just throw a paper here real quick. Okay, remember, you have a number line. Here's -8, here's 4. You don't want them to equal those numbers, right? So you're going to have this little interval, and this little interval, and union them together, right? So we're going to have -infinity to -8, the fat bottom u with -8 to 4, fat bottom u, 4 to infinity. Good question. He doesn't have a bracket because we don't want him to equal that. We don't want him to include him. So all parentheses for a denominator. So you might want to put up here all parentheses for your denominator. Okay. And that's going to be your answer. So the only time you have a hard bracket in a domain is when you have a radical. That's it. Okay. No denominators. That one all right with everybody? Okay. All right, let's look at 21 then. Okay, 21, read the directions kind of on your own so that you don't get thrown by what these directions say. Sometimes students, it bothers them, they don't know what to do. The key here is they just want you to find the inverse. So you don't have to worry about B, the answer's range, because you know your domain range flip, but you won't have that one. All you have to do is find the inverse, okay? Is it all right if I take this one off of here? Okay, all right, so if I want to find the inverse of this guy, my first step is I'm going to make this a y, okay? So I'm going to have y equals 3x minus 4. That's my first step. My second step is that I'm going to switch the x and y. It's kind of like you just took a little knife and you just cut out the x and moved them and put the y back in. Leave the coefficient, leave the exponent, leave everything else behind. Everybody okay with that? Now you're going to solve for your new y. Okay, so now I'm going to solve for my new y. So I'm going to add 4 to both sides. Okay, I'm going to divide by 3. Okay, everybody all right with that? And then I have a cube on my y. So how am I going to get that off? Okay, we're going to cube root it. Okay, to get that cube off. And then we're going to be left with the cubed root of all that stuff you did, x plus 4 over 3. Okay, if you leave it like that, I'll take it. But technically, you're supposed to change that y back into inverse notation. This is supposed to be the answer, but I'll take it if you leave it like that. It's fine. Okay, so notice we did the opposite of everything that happened in the original. Look at what we did. We added 4, we divided by 3, and we took a cubed root. Does that make sense? Because we were subtracted by 4, multiplied by 3, and cubed. So an inverse is just the opposite of every action. That's all. Okay? Is everybody okay with that? All right, last page. Okay. All right, I'm going to add a C onto 22. Okay, so we're going to do A and B, but let's add on a C because I realized I didn't have one like I wanted. Okay, so let's add on one on there. That might be a great hint. Okay, here we go. So we want to know, is it even, odd, or neither? So an even has even exponents. An odd has odd exponents. Neither is mixed. But there's one other situation that falls in. This is where students get confused. Remember, constants, constant numbers that don't have letters are considered even. All of them, even if it's an odd number, even if it's 5 or 17, constants are considered even. That's because it's supposed to be like they have an X with a 0. Oh, that would help. Sorry, guys. Okay, so it's like they have a 0 exponent, which is considered even. Okay, so you can only have constants with even. That's it. If you have a constant with odd exponents, it's neither. Okay, you can only have constants with even. So let's look and see. Okay, let's forget constants for a minute. Let's just look at exponents. Okay, I have a 3, well, that's odd. But then I have a 2, that's even. So what is this guy here? He's neither. Okay, we don't even have to look at the constants. Let's look at this guy. All right, that's even. That's even. Okay, last thing we check is it has a constant. As long as the exponents are even, we can keep it. He's even. Okay. All right, let's look at C. Odd. Odd. So far we're good. Oh crap, he is a constant. All constants are what? Even. So what is C? Neither. So the only way to get an odd ever is to not have an exponent. That would be odd. I'm sorry, to not have a constant. That would be odd, okay? That's the only way you can ever have an odd, is no constant. Is that okay? All right, so pay really close attention to C, okay? All right. Okay, let's look at 23. Find the center and radius of the circles. All right, we need another formula in here. Okay, so remember your standard form of a circle is this. Okay. All right, 23A is a regular test question. 23B is a bonus. All right, everybody okay with that? Okay, so all they want you to do is find the center and the radius. So here we go. A is already in the form you want. That's why it's a regular test question. Keep in mind your center is the opposite sign, right? Because these are minuses in the formula. So your center is not 2, -3. Everybody see that? What would my center be? -2, +3. Okay, what's my radius? Okay, so this one, it means that this number here is squared. So to find your radius, you take the square root. Okay, square root. So it's 3. Okay, and a radius is a distance. So you just take the positive, the 3. Okay, so make sure if you need to write on here that you have to take the square root. There you go. Is that good? Okay. All right, now here's the bonus. All right, the bonus is you're going to be given this. This is general form. You have to turn it into standard form, and you have to find the center and the radius. Okay, so let's see if we remember how to do that. So you want to put your X terms together, leave a blank, your Y terms together, leave a blank, move your constant, and leave 2 blanks over there too. Okay, so we're going to have x squared minus 10x, and we're going to leave a blank. Then we're going to have plus y squared minus 6y. We're going to leave a blank. All right, this is a minus 30. So what's he going to be when I move him to the other side? Plus 30. Now I have 2 blanks on the left, so I better have 2 blanks on the right. Everybody okay with that? All right, what do you put in the blank? Remember, b divided by 2 squared is what goes in the blank. Everybody okay on that? Okay, so what's the b for the first blank? -10. Negative 10 divided by 2, negative 5, squared, 25. Okay, so put it on the left, but you better go ahead and put it on the right also. All right, what's the B for the second blank? Negative 6 divided by 2, negative 3, squared, 9. There we go. Okay, now we're going to make our parenthesis and square it, plus our other parenthesis and square it. We're going to add all these together over here on the right. We get a 64. Okay, square root of the first term, sine of the middle, square root of the last. Square root of the first term, sine of the middle, square root of the last. And now you're in standard form. Okay, let's talk about our center. What's our center? 5, 3, right? Opposite signs, 5, 3. Where did these minuses come from? Remember, that was just right here, sine of the middle. And then what's our radius? 8, because we take the square root of 64. Now, I will tell you, I will warn you, the bonus is pretty hard on this. That's why you got 3. Your center and your radius for your bonus are going to be fractions. They're going to be fractions, but that's okay. You can do this. They're not hard. You can do it. Okay. All right, let's look at 24. She said fractions. It's going to be all right. Follow your steps. Okay. All right, now we need the distance and the midpoint. We need formulas. Okay. So I think I can squeeze it in. I know, it's start practicing. Okay, here's your distance formula. Remember, you're going to subtract your points and square them. Okay, and then add them together. All right, you're going to need your midpoint. That's a point. All you're going to do here is add them and divide by 2. Somewhere deep down back in your brain, those are still stored in there. You use them at some point in geometry or algebra 2. They're there. You just have to do an update and pull them out or something. Okay. All right, be careful. This problem is going to be just like on the test. It's going to ask you to find both in the same question. A lot of students get about this far in the question. Find the distance. Boom, they find it and move on. They never read the fact they also have to find the midpoint. You're going to have to find both in the same question. So make sure you read that. Okay, here's x1, y1, x2, y2. Okay, let's find distance first. Square root. Okay, x2 minus x1, and then we're going to square that. y2 minus y1, we're going to square that. Okay. 1 minus 3 is negative 2. What's negative 2 squared? 4, positive 4. What's 11 minus 8? 3 squared, 9. The distance is the square root of 13. That's ugly, but that's it. You're good. Everybody okay with that? Good. Okay. All right. Let's talk about midpoint. Okay. We're going to add them together. So if I add x1 and x2 together, 3 plus 1 divided by 2, I'm going to add y2 and y1 together, divided by 2. Okay. That's going to give me 4 divided by 2 is 2. 19 divided by 2 is 19 divided by 2. And there we go. Okay. I know we got to hurry. Let's talk about the very last one. This is a bonus. Okay, very last one. Okay, so all you're going to need to do for this bonus is describe what is happening. So for A, let's describe the transformation. The original was x squared. Okay, so remember, hippos seem really violent. You don't have to have them in the right order, but sometimes that'll help you remember what to put. Okay, is there any horizontal action in A? Yeah, he's going 2 units where? To the right. Remember, it's the opposite. If it's minus, you're going to the right. If it's this one. Sorry. Okay. All right. I have no stretching or shrinking. I have no reflections, but I'm +1. So what is that? 1 up. Yeah, or up 1. Okay, let's look at this one. This one is super ugly. This one is so confusing. Your bonus is going to be real similar to this. Combine these guys on the outside. This is what you want to start with. Okay, you want to start with this dude. See how I combined the 8 minus 4? That's what you want to do, combine. Now let's see what's happening. Okay, horizontally, I'm moving 1 where? Yeah, 1 unit left. Okay, I have no stretching or shrinking. You won't on the test either. I am reflected. Where am I reflecting? The negative is outside here. The x-axis. When it's outside the parentheses, it's on the x-axis. Okay, and then I have this 4. Where's it going there? Up. And that would be your bonus. Okay, so the secret is to combine those first. All right, that's it. So I will see you Tuesday. Let me know if you have any questions. If there's more donuts, grab a donut.